Have you ever wondered how your car's engine works? It's a marvel of modern engineering, a testament to human ingenuity. Engines, they're not just the heart of your car, they're the power behind every journey, every road trip, every commute. In this video, we're going to pull back the curtain on these mechanical wonders, breaking down the mystery of how they transform fuel into movement. So buckle up and prepare for an enlightening ride. Stay tuned as we delve into the fascinating world of internal combustion engines. At the heart of your car is an engineering marvel, the internal combustion engine. An internal combustion engine is aptly named, as it's all about combustion happening internally or inside the engine itself. It's a power-producing machine that generates energy by burning fuel within its cylinders. This energy is then converted into motion, propelling your vehicle forward. The concept of an internal combustion engine was born in the early 19th century, with the first successful model developed by Belgian engineer Etienne Lenoir in 1860. However, it was Nicolas Otto's four-stroke engine, invented in 1876, that really set the stage for modern automobile engines. This groundbreaking invention revolutionized transportation, paving the way for the motorized vehicles that dominate our roads today. So, how does this mechanical marvel work? At its core, an internal combustion engine operates on a simple principle. It uses the energy produced by the combustion of fuel and air to move pistons. These pistons, in turn, rotate the engine's crankshaft, which is connected to the vehicle's transmission system, ultimately driving the wheels. The process starts with the intake stroke, where the piston moves down, creating a vacuum that sucks in a mixture of air and fuel into the cylinder. Next is the compression stroke, where the piston moves back up, compressing the air-fuel mixture. The power stroke follows, where a spark from the spark plug ignites the compressed mixture, creating a small explosion that drives the piston down, turning the crankshaft. Finally, in the exhaust stroke, the piston moves back up again, expelling the burnt gases out of the cylinder. This four-stroke cycle repeats over and over, thousands of times per minute, and it's this rapid, continuous combustion that generates the power to drive your vehicle. Now, you might be thinking, that sounds complex, but don't worry, we'll break it down step by step. The first step in how an internal combustion engine works is the intake stroke. This is where the magic begins, setting the stage for all the action that follows. As we delve into the details, try to imagine a four-stroke engine, which is commonly found in most cars today. Picture the piston at the top of the cylinder. As the crankshaft drives the piston downwards, a void is created above it. This movement is akin to drawing back on a syringe, creating a vacuum. Simultaneously, the intake valve swings open. This is not a random occurrence, but a perfectly timed sequence. The opening of this valve is like opening a door to a party. It invites the guests in. In this case, our guests are air and fuel. The air and fuel mixture rushes into the cylinder to fill the void created by the descending piston. It's like a gust of wind entering a vacuum. This mixture, also known as the charge, is crucial. It's the right blend of air and fuel that will later ignite to produce the power that drives your car. Bear in mind, it's not just any air that gets in. It's a calculated amount controlled by the throttle. The more you press the accelerator, the more air is allowed in and consequently more fuel, resulting in more power. With the fuel and air mixture in the cylinder, we're ready to move on to step 2. Next up in our journey through the internal combustion engine is the compression stroke. This is the moment the engine begins to show its real power. Now, imagine the piston at the bottom of the cylinder, having just finished the intake stroke where it drew in a mixture of air and fuel. As the piston starts to move back up the cylinder, the intake valve closes. Imagine a tightly sealed chamber with no place for the air and fuel mixture to escape. This is what we're aiming for. As the piston ascends, this mixture is squeezed into a fraction of its original volume, kind of like packing an overstuffed suitcase. This compression of the air and fuel mixture increases its pressure, making the mixture more volatile. It's a bit like shaking a soda can. The pressure builds up inside, ready to burst out with great force when the tab is pulled. And it's this principle that the engine uses to create power. By compressing the air-fuel mixture, the engine prepares it for the ignition by the spark plug. This is the magic trick that turns a simple mix of air and fuel into the driving force that powers our vehicles. The higher the compression, the more powerful the explosion, and consequently, the greater the force exerted on the piston. With this, the engine is ready to move into the next phase. With the mixture compressed, we're set for a big bang. Now let's move on to the power stroke, the real heart of the process. This is where the magic happens, where the rubber meets the road, so to speak. Imagine the piston at the top of its journey, nestled in the combustion chamber. The air and fuel mixture has been squeezed into a tight little package, just waiting for that spark. And that spark comes from none other than the spark plug. The spark plug, strategically located, sends a jolt of electricity across a tiny gap at its tip. This electrical discharge ignites the highly pressurized mixture of air and fuel. The ignition of this mixture results in a mini explosion of sorts. This explosion creates an incredible amount of heat and pressure, and it's this pressure that forces the piston down the cylinder. This downward movement translates into a rotational force as it turns the crankshaft. It's like a team of tiny, fiery horses galloping in unison, driving your vehicle forward with their combined strength. But wait, it's not over yet. This powerful stroke isn't all about brute force. It's also about precision. The timing of the spark is critical. Ignite the mixture too soon and you'll cause knocking. Too late, and you'll waste potential power and efficiency. This intricate dance of power, timing, and precision is what makes the internal combustion engine such a marvel of engineering. After that explosive action, there's just one step left. Finally, we arrive at the exhaust stroke, the cleanup crew of the engine cycle. As the final act in our engine drama, the exhaust stroke plays a crucial role in maintaining the engine's efficiency and overall health. Picture this: the piston, having done its work during the power stroke, begins its upward journey. As it ascends, the exhaust valve, which has been patiently waiting, swings open. This is the moment it's been waiting for. It's time to shine. With the exhaust valve open and the piston on the move, the cylinder becomes a sort of expressway for the exhaust gases. These gases, byproducts of the fuel-air mixture's combustion, are no longer needed. They've done their job, given their all to push the piston down during the power stroke. Now they're just taking up valuable space, and it's time for them to leave. The rising piston acts like a broom, sweeping these spent gases out of the cylinder and through the open exhaust valve. It's a swift, efficient process, one that's repeated countless times in a running engine. As the piston reaches the top of its stroke, the exhaust valve closes, sealing off the cylinder once more. The cylinder is now clean, empty, and ready for the intake stroke to begin anew, drawing in a fresh charge of fuel and air. And just like that, our journey through the internal combustion engine is complete. Let's summarize what we've learned about the internal combustion engine. At its heart, this ingenious mechanical device is a symphony of carefully timed movements and reactions, all working together to convert fuel into motion. It all begins with the intake stroke, where the piston descends and a mixture of air and fuel is drawn into the cylinder. Then, the compression stroke sees the piston rise, squeezing this mixture into a tightly packed ball of potential energy. The power stroke follows, where a spark ignites the fuel-air mix, causing an explosion that pushes the piston down, turning the crankshaft. Finally, the exhaust stroke expels the spent gases, preparing the cylinder for a new cycle. This four-stroke cycle, repeated thousands of times per minute, is what propels your vehicle down the road. So next time when you drive your car, you'll know the intricate dance happening under the hood.